Hello friends, today I am going to discuss the interpolation and decimation using some software. So it is better to learn decimation and interpolation with MATLAB actually, but we don't have that software. 90% of our students, we are not having the MATLAB software. We don't need to worry about this. Without software, if I explain also, it will not be convenient for you to write programs and all. So I prefer in this contest I would like to use the Octave, which is very 100% it is similar to MATLAB, and most of our researchers also, even in IITs also, they are using Octave software, and it is very good start even for neural networks and image processing and signal processing, all other applications. So I am preferring the Octave software. Here it is the Octave software. You can download it freely. It's open source software, everybody can download. So in sourceforge.net, so directly if you click on Google, directly you will get this software, and I will now show you how to do certain programs with Octave software. So you see here, before starting with Octave, let me this command window is similar to the MATLAB software only. We have editor window where you can write your program and you can execute by run command. So let us first, before going to this, first we need to check package and list. If you check packages, which packages are available, it will show, and we require the signal 1.4.1 for our signal processing applications. It is already there with your latest version, but the most important thing is sometimes you may get error that it is not loaded. So if you want to load that, you can easily load. If you are getting any error, go with package load signal, and I recommend after first installation you do this so that you will not get any errors. So that is the thing, package load signal. If you do, you can write all decimation and for those things very easily. So now let me explain a simple commands. For example, x is equal to 1 2 3 4. Let me start with this series. It is similar to the MATLAB. Y is equal to, let us suppose, 5 6 7 8, and now if I want to add y z, for example, z is equal to x plus y, so you will get answer here. So then next one is covariance matrix. Let me explain the covariance matrix. What is covariance matrix? Is the covariance matrix measures the relation between how x variable varies, in what direction it varies from y. So one variable, how it is varying with another variable, will be defined by covariance, but covariance will not give the exact measurement. So if you want exact measurement between the relation between x and y, if you want to know, you have to go with the correlation matrix, and all these formulas I will explain later in my other video. So for x, covariance matrix means covariance of x comma y, so it will give the covariance value. For example, if I take y is equal to some bigger difference, 1 10 50 and 60, if the difference is more, definitely you need to get a covariance matrix of x comma y should be more. So 36.167. in the previous case we have got only 1.667. that is the difference between the that is where you can estimate how the x value is varied from the y value. So that means we can understand the difference means how exactly it is deviating with the y, x is deviating with the y. So and all these things are very useful for artificial intelligence and statistical signal processing and all other applications. So for now let me explain the decimation function. X is equal to random 1 comma 1000 generates for example 1 comma 100 generates 100 random values. Now you see so many random values are there, so within the limit 0 to 1, so it generates the random values within limits 0 to 1. Then plot x, for suppose similar to MATLAB, plot x, you are getting the plot x value. And if you use a simple command called decimate function, decimate of x comma, you need to mention 4. For example 4 means 3 number of zeros will be added. Now plot answer, you are getting a different signal, so that means the decimation definitely loses certain information and you will get a different signal than the original signal. So loss of information is there in decimation, you can understand it very easily. And the spectrums also now so similarly you can, for example if you want to know more about decimation, you can go with decimate, help decimate, that gives you the documentation, examples. You can see the chip signal and how to generate the chip signal. Here the example is there. Right click, copy, and you can paste it in command window, the editor window. So first command is t is equal to 0 is to 0.1, 0.01 is to 2 means the t value ranges from 0 to 2 with the interval of 0.01, and we are using a chip command and sine function, we are mixing these two, and x comma 4 is the decimation. Now let us see how to run this. Run, save file and run. File name, use something. Now you see the difference between the original signal and the another signal. So after decimation you are getting certain samples only. So and we are leaving these samples, all these samples we are leaving. It's a very good example. The red color is a decimated signal and green color indicates the original signal.